permutation with condition. Consider 7 objects in the diagram below. Suppose all the above objects are to be arranged according to a certain condition. So, let's see the condition. Then the following condition should be followed. The condition number 1. If each circle and triangle must be arranged alternatively. What it means by alternatively, it means the circle and triangle arranged alternatively. So we can start with the circle followed by triangle and circle, triangle, circle, triangle, circle. So number of ways to arrange 4 circles with different color is considered 4 different objects, which is 4 factorial. So 4 factorial, it means 24 ways. So there are 24 ways to arrange those 4 circles. How about number of ways to arrange 3 triangles? 3 triangles consider 3 different color triangles. So we will use 3 factorial, which is 6. So there are 6 ways. By using the multiplication rule, the numbers of possible ways to arrange follow the condition given, whereby the circle and triangles are arranged alternatively. So the number of ways is 4 factorial times with the 3 factorial. So the answer will be 24 times 6. So the final answer is 144 ways. So we have to follow exactly the condition given, and then we have to follow the multiplication rule. So let's see condition number 2. If all the circles are always together, sometimes we will say they are adjacent, or we can say they are not separated. So if all the circles are always together, we can consider the 3 circles are together at the in between the triangle. So this is one of the possible ways. So let's try to arrange the first event. We must make sure all the circles are together. So we group the circles and we need to arrange them in the group. And also we have 3 triangles. So number of ways to arrange a group of circles and 3 triangles is 4 factorial. Why? Because we consider the 4 circles now is putting into a box. Alright, into a box. We want them to be together, so we actually put them in a box, and it's considered one object after we put in the box. But then numbers of ways to arrange the group of circle in the box. In that box is 4 factorial, because we have 4 different circles. So we have 24 ways. So by using multiplication rule, number of possible ways to arrange is 4 factorial times 4 factorial. Be careful, it's not 5 factorial, it's 4 factorial. Alright? So 4 factorial times 4 factorial. So the answer is 576. Right? So 24 times 24. So the answer is 576. Please bear in mind the 4 circles now become one object. Then we proceed to condition number 3. If circles and triangles have to be arranged in their respective group. In their respective group means the circle is at the left and the triangle is at the right. Alright, so we can just group the triangle into a box and then group the circle into a box. So now we must write the number of ways to arrange all the circles together in front of the line. All the circles together. We have 4 different circles. So we need to follow by the 3 triangles after we arrange the 4 circles. So we have 4 factorial times 3 factorial. If we arrange the 4 circles and if we arrange the 3 triangles which are different color, so now consider that the group of triangle can be putting at the left and the group of circles can be putting at the right. So that is another possible way, because it's actually showing that the triangles and the circles are in their respective group. It's just that they can be at the left or at the right. So the total numbers of ways is we need to multiply the answer by 2. So we can write 3 factorial times 4 factorial equal to 144. We just multiply the answer by 2 because the numbers of ways will be double. Or you can say that you just plus a 144 plus 144, so the answer is 288. Alright, so you can either times 2 or you just plus them, 144 plus 144, so the answer is 288. Let's see example 10. Find the number of ways to form 4-digit odd numbers from the digit 1, 3, 4, 5, 6, 8, and 9 without repeating any of the digits. So repetition is not allowed. Now the first condition is an odd number. So in order to form the odd number, it is a must to end with an odd digit. So that means there are 4 ways to fill the last digit, because we have 1, we have 3, we have 5 and 9 which are odd digits. So the ending digit can have 1, 3, 5 or 9. So we have 4 ways to end with. Either we can end with 1, we can end with 3, we can end with 5, we can end with 9 in order to get the odd number. Alright, so now we want to make sure the 4-digit number that we form later is an odd number, 4-digit number. After one of the odd digit has been filled up the last space, there are how many more digits for us to arrange for the 3 space? Of course, you just count how many digits you minus out 1. So you have 1, 2, 3, 4, 5, 6, 7. So 7 minus 1, meaning that we have 6 more digits. 6 more digits is going to fill up the 3 space. So we write 6p3. Alright, 6p3. And we have to times with the 4 because we have 4 p1 ways to end with. So the total number of ways is 480 ways. Alright, so make sure you really follow the condition given by the question. Let's see example 11. Find the number of ways to arrange 5 employees A, B, C, D, E from a company at a round table, if A and B must be seated together. So when A and B are seated together, we consider them as one box. We put them into a box. So we consider them is one entity, one object, or one unit. So the number of ways to arrange the one unit, one box, you just remember there is a box consists of A and B. So there are two ways for us to arrange A and B, isn't it? Alright, so we have A and B consider one unit and three others. So we have four objects actually. The box consists of A and B and three others. So we actually just take the 4 minus 1 factorial. So we have 6 ways. And A and B can be interchanged among themselves in 2 ways. Right? So it's either AB or BA. So it's 2 factorial. Hence the total permutation are 6 ways times the 2 ways, 2 factorial ways. So there are 12 ways. So for cases like together, we always consider that we are actually pack them into a box. So we consider that is one object. Alright, plus another 3. Okay, so it becomes 4. Find the number of possible ways to arrange all the letters in the word swasana if the vowels are always together. Be careful, we have many identical objects. So vowels, we have U and A, right? So given that the number of letters, okay, so we have 1, 2, 3, 4, 5, 6, 7 letters. Alright, so we have also the identical letters. So we can see that we have 2S. Alright, we have 3A. Okay, so later we need to divide by 2 factorial and 3 factorial due to the identical letters. So the total numbers of ways to arrange so that the vowels always together are, group the vowels first. We have vowel U and A to form one unit. That means you put the U and A into the box and then you seal the box and you arrange a box with the balance, alright, which are not vowels. So now we will actually pack the U with the 3A into the box, but the number of ways will be counting later. And then later the box consists of U, A will be arranged with a S, and N. So the number of arrangement together with the other 3 letters is 4 factorial because we are arranging the box with the 3 letters. But due to repetition for the S, we have 2S, so we have to divide by 2 factorial. Alright, that is settled for us to make sure the vowels are together. But don't forget, in the group of the vowels which are together, we need to find the numbers of ways to arrange them. We have 4. We have U, we have A, we have 4 objects, but they are repetition of the A 3 times, identical A, so we divide by 3 factorial. Thus the number of ways to arrange such that vowels are always together is 4 factorial over 2 factorial, and then we need to times with a 4 factorial over 3 factorial. Alright, so make sure you are very clear about the condition whereby the vowels are always together. So hence the answer should be 4 factorial over 2 factorial times 4 factorial over 3 factorial. Let's see the example 13. Find the number of ways to form 4-digit numbers from the digit 2, 3, 5, 7 if the numbers must be odd and less than 5,000. So we have two conditions. One, it must be odd and it must be less than 5,000. To form the 4-digit number, we have to prepare the 4 empty boxes, or you can draw 4 lines. 4 empty boxes because of the 4-digit numbers. Now we have to fulfill the condition. First condition is it must be odd, so we have to end with either 3, 5 or 7. So we have 3 ways to end with. For the number to be less than 5,000, the first box consists of a digit that must be less than 5. So we have 2. We can start with a 2. We can start with a 3, but we can't start with a 5 because the condition is it must be less than 5,000. So thus 3 starting and the ending. Okay, so it seems like we have to be very careful with this question because the 3 cannot be using at the same time. So if 3 is used for the first box, then that means we cannot use back the 3 to end at the last space. So let's say we still want the 3 in front at the first space. So we have only one way because we chose the 3. Now we want to see if we choose 3, then we can't end with 3. We can only end with 5 and 7. So we have 2 ways to end with. So this is one of the possible arrangement. Okay, so we left only 2 space. So out of how many digits we have? We have 2, 3, 5, 7. Out of 4, we have used up 2 digits. So left only 2 digits. So it's 2 times 1b. Finally, we can just write the answer is 1 times 2 times 1 and times with the 2. Alright, so the answer is 4. For the 3 is used for the last box. We can end with 3, 5, 7. There are 3 ways to end with. So if we end with 3, we cannot start with a 3. Alright, so we only left 2, right, to start. So let's see, we are going to start with a 2. So we got one way, we have only 1 2, right? So the digit 2 is one way. Then the balance, we have 4 letters. We use up the 2 letters, so it'll be 2 factorial or 2 times 1. But then we have 3 ways to end with. We can end with 3, 5 and 7. Either 1, either 3, either 5, either 7. 3, 5, 7. So we have 3 ways to end with. So total numbers of ways will be 1 times 2 times 3. So we have 6 ways. So for cases like this, we need to do it separately. Okay, and then we plus. So the total numbers of ways is actually 4 plus 6, which is equivalent to 10 ways. So for cases like this, whereby there is an overlapping of the digit used, we have to do it separately, and we need to plus them after we do, because there are two possibilities.
Here I am where the movie started, facing at a photo they've taken. Space tree flying through the skies, and battles happen everywhere. I don't need any hero to save me. I don't know why the kids always crying. I've been thinking about all the captains, but we left in a wasted planet. I thought I had